we have been discussing about the different aspects of micro robotic system, especially in terms of selection of materials, the parameters involved in selection of materials for different domains and subdomains which are being efficiently used for micro robotic designs. Now, we had discussed about the selection of the sensor material, selection of the actuator material, selection of the structural material, about the different types of material used for sensing applications in micro robotics, different materials used for actuators in micro robotics, and different materials which are used for kind of like structurals in micro robotics, etc. Now, we have been discussing about this power source materials, the parameter required for power source materials, in which we had discussed about the energy density, the charging and the recharging capability of the material, and the weight and the flexibility of which is one of the major requirement for this power source materials. Now, as far as in this power source materials is concerned for a micro robotic application, so like material like lithium has a potential application. So, basically for kind of thin film battery for energy storage, graphene for supercapacitors for fast discharge applications, a biocompatibility like self-powered micro robots, and a copper and a silver structure for antennas for remote powering, etc. So, these are some of the different power source materials which are being commercially available. Sometimes these are being developed based on the requirements or based on the functionality. For developing all these power source materials also, these microfabrication plays a vital role. So, either in most of these thin film battery related applications, so people used to use a sputtering technique, people used to use a e-beam based technique, lithographic techniques are efficiently used for fabricating such kind of power source materials, making it compatible for the micro robotic related applications. So, an thorough exposure on these microfabrication related application, microfabrication related methodology is required to appropriately tailor these materials based on the application or based on the characteristics. Now, when we try to talk about control and communication materials, control and communication plays a vital role with reference to micro robotics. Either it might be a one-to-one communication where from the control to the concerned actuation base to the micro robotic system, or it is a kind of a communication between two micro robots, especially when we are talking about the swan robot based applications or kind of micro drones, coordination of micro drones related applications which we had seen in the introductory slide. So, those are some of the examples where we can directly deploy such kind of micro drones or micro systems, like where a communication and control play a vital role. So, these control and communication materials has certain parameters which we may need to consider. One parameter is with reference to power consumption. So, as far as power consumption for a control and communication material is concerned, it should be low to achieve a long duration of operation for a battery operated micro robots. As far as processing speed perspective point of view, it requires a high processing speed and is required to achieve a real time control and response of a micro robot. As far as miniaturization perspective point of view, its size should be minimal for proper integration of the system. And then we have a kind of a thermal stability. So, thermal stability plays a vital role. Ideally, whenever when such kind of actuation or sensing happens, or wherever such kind of system works upon, there is a need to go for a thermal stability. So, a control and communication system should be thermally stable and prevent overheating within the micro robot. And most important aspect is with reference to electromagnetic compatibility, that is the signal which is being generated from such kind of actuators or such kind of sensor systems should not interfere with the external electric component what we are working upon. Now, as far as this material perspective point of view, there are different types of materials which are being efficiently used for control and communication. Like as far as antennas are concerned, so it is highly required that these antennas are kind of a wireless communication circuits. So, in the case of antennas, the most of the material which is used are gold, silver and copper. In the case of flexible chips, so we have a graphene in place, which is efficiently used. So, in the case of antennas, so since we have such kind of materials, so in most of these micro robotics related applications, so the antenna which is used for communication are kind of a patch based system. So, thus these patch based systems are kind of a lightweight system which has a capability to get integrated within the system. Next, in the case of an integrated circuit, we have a silicon. Of course, silicon is considered to be a dominant material with reference to any kind of microelectronics related application. For micro robotic perspective point of view, these kind of materials has a potential aspect towards the behavior. Then we have a kind of an ultrasonic communication. So, as far as an ultrasonic communication is concerned, piezoelectric crystals play a vital role, especially PZT and zinc oxide based piezoelectric crystals are efficiently used for kind of an ultrasonic communication and related applications. Then we have a flexible antennas in place. As far as in this flexible antennas are concerned, the conductive polymers are efficiently used, and in addition to conductive polymers, certain amount of metallic interconnects are also being efficiently used for fabrication such kind of flexible antennas. In fact, on a manufacturing perspective point of view, in fabricating these antennas, micro 3D printing has a potential applications in fabricating these antennas directly on the devices or directly on the micro robotic system based on the application or based on the like functional behavior. Now, in addition to this, when we try to talk about the future materials, the materials what we are focusing upon should have a kind of a lightweight, and it should possess a high strength to ensure the energy efficiency and durability. The system should have a high durability as well as the system should have a capability to go for a higher order requirements. Then the one of the most important parameter is with reference to the biocompatibility and biodegradable. So, on a biocompatible perspective point of view, so when we try to look into it, the system what we are fabricating or what we are emphasizing should have a biocompatible capability. In the meantime, when we are talking about the sustainability of the system, the biodegradability of the system also plays a vital role towards the requirement as well as towards the characteristics. Next, when we try to talk about an energy consumption point of view, it should be the energy consumption, it should be an operational with a minimal input power. That is like we had discussed a lot about this energy consumption. Still, there is a huge amount of requirement towards usage of these materials or selection of these materials which can consume or which can operate at a minimal input power. Then we have a self-healing and self-assembly capability, as well as self-healing or self-assembly capability is concerned. So, this is one of the prominent property, so which is of recent demand. So, in this prominent property, if you see, like whenever there is a defect state is there, automatically the material should have a capability to self-heal and to retain its functionality based on the requirement. So, when we try to talk about functionality, which includes the structures with which also includes the electrical behavior and other characteristics what we are looking upon. There are wide varieties of self-healing materials are there. So, when we try to talk about the biodegradable perspective point of view, so one of the important point is with respect to the temporary implants, bio-integrated robots and a muscle powered robots. A bio-integrated robots means these kind of micro robots which is implanted along with the tissue and it works with the tissue for the required characteristics. As well as muscle power robots are concerned. So, these muscle power robots are like normally kind of polymer based robots which are available, which basically gives a required energy density for different applications. So, in this particular aspect, there are some materials which directly has a relevant application towards biodegradable. So, one is called as a biodegradable based system, and another set of robots are called as a bio inspired material. So, like silk, Fibrion and gelatin are considered to be some of the promising materials which has a direct application towards temporary implants, a bio-integrated robot as well as a muscle powered robot systems. Next, when we talk about the smart and a responsive material, stimuli response polymer plays a vital role. As far as the stimuli response polymer is concerned, like stimulus action or the immediate response action with reference to an actuation is a kind of a, it has a direct relevance towards the response time of the system. So, these micro robots function which changes in external stimuli such as light and humidity can be appropriately used for generating or for establishing such kind of smart and responsive materials. So, there are wide varieties of materials which has a kind of capability towards this stimuli response polymers. Like in fact, when we are discussing about the different types of these polymeric materials for actuator application, we will be discussing these polymers also. Then we need to, when we try to talk about a self-healing materials, polymers, hydrogels that can achieve a self-repair comes under the category of this self-healing material. So, as far as in this self-healing materials are concerned, like for example, as I had mentioned earlier, like it should have a capability to retain the functionality based on the even when there is a defect state is observed, and appropriate characteristics can be retained by these self-healing property. So, there are a certain amount of polymers and hydrogels which has a capability towards this self-healing capability. Now, to summarize, so we had discussed about the overall like key factors for material selection. Under the key factors for material selection, so we had discussed about the mechanical property, we had discussed about the electrical and the magnetic property, the biocompatibility, the ease for manufacturing, and the environmental stability. So, we, with reference to structural material perspective point of view, we had discussed about the different process parameters which affects the structure of the material. So, we have also discussed about the overall different types of materials and its applications. Then we had discussed about the actuator material and its applications. So, we have also discussed about the sensor materials and its applications, the power source materials and this application, basically on the kind of external energy based power source and energy efficient power source, etc. Control and communication materials and its appropriate applications. And then we have also discussed about the future materials, in which some of the key component which includes the biocompatible and the biodegradable, the energy consumption and the self-healing are considered to be the additional material which comes into the picture. Now, we will discuss about one of the important aspect of this micromechanical system, that the micromechanic system design is the controls of surface walker. That is a kind of a propulsion, like the micro robot used for walking on a surface can show various kinds of motion such as walking, crawling, rolling and jumping, which are considered to be one of the major characteristics. In fact, in other term, we can also say that propulsion of these micro robots is itself is a kind of a, it has various classification based on the kind of environment what we are using, or based on the type of functionality what we are using. So, we may need to select an appropriate mechanism, or we may need to incorporate an appropriate mechanism to these micro robots to generate a kind of a motion. So, as far as this surface walking of micro robots are concerned, so like one of the key, so we may need to look into some of the key parameters, like we may also need to study the different parameters which influence the control of the surface walker. So, the surface walking of a micro robot experience various forces during the motion. One is a kind of an external force which exists. So, when we try to talk about the external forces, we have the gravitational force which is represented as Fg. We have a normal support which is represented as Fn, a frictional forces which is represented as Ff, and the air resistance drag force which is represented as Fd. Similarly, when we try to talk about the internal forces, it is generated by the robot, where there is a propulsion force Fp, an adhesion force Fa, and a torque for legged motion which we call it as a tau. Now, we will see how these parameters are taking up are influencing the overall propulsion of a micro robot. So, when we try to talk about the external forces, so we have a gravitational force which we are representing as Fg. The weight of the micro robot is pull it's downwards due to the gravity, and it is given as Fg equals mg, where m is the mass of the micro robot and g is the acceleration due to gravity. Similarly, when we need to investigate the normal forces, which we call it as Fn, so the normal reaction to the, so this is the normal forces which is being generated, and this is due to the gravitational force. The normal reaction to the weight, it is given as Fn equals mg for motion on horizontal surfaces, and Fn equals mg cos theta for motion on inclined surfaces, where Fn is the normal force and theta is the angle of inclination of the surfaces. Now, we may need to consider the frictional forces. So, it is the resistant force of the surface on the micro robot. It provides a necessary traction for walking. It is given as Ff equals micro Fn. So, Fn is the kind of a normal force which exists. Ff is a kind of a frictional force which is represented over here, and Ft is the kind of a drag force which is being generated over here, and Fg is kind of a gravitational force which is exerted over here. So, Fn, when we consider Fn as the normal force and mu is the coefficient of friction, since we are considering the frictional force which exhibits over here. Now, let us take the drag force. So, as the size of the micro robot is very small, the force acting on it due to the surrounding air becomes a significant during motion. So, it gives Fd equals half Cp a v square, where C is the drag coefficient, P is the rho is the density of the surrounding air. Since it is on a micron level, of course, the density of the surrounding air will have an impact on the propulsion of these kind of micro robotic system. A is the surface area of the micro robot which is in contact with the air, and v is the velocity of the motion which pursues in the system. Now, when we try to talk about the internal forces, so one of the key forces which exhibits in an internal condition, which we call it as a propulsion forces. So, as far as these propulsion forces are concerned, it is the force generated by the leg, wheel or the other actuator to generate the locomotion of the micro robot. To achieve a significant movement, the propulsion forces has to be greater than the summation of the resistive force. So, let us consider for motion of Fp which is greater than Ff plus Fd. So, like if we consider this as our system where we are having an Fp, Fp is nothing but the propulsion force which is a kind of a total force which is generated by all the legs, and this nomenclature the parameters of Fp basically depends upon the n into F1. So, n is the number of legs and F1 is the force generated by each leg. So, this n is denoted by the capital N and F1 is the force generated by each leg. So, for motion when Fp is greater, then Ff plus Ft comes into the picture, that is for legged micro robot, the proportion of the force is total forward force generated by all the legs. Similarly, let us in this particular case, once again we have a kind of a micro robot. In some cases there is a kind of an electrostatic adhesion force to the which sticks to the surface. This, that is like let us consider if we have a kind of a legged robot. So, in the case of a legged robot, so the adhesion of this legged robot to the surface will have an impact towards the motion. So in those conditions there is a need to consider the adhesion force. So, the adhesion force here is nomenclated as epsilon A v square by 2d square, where epsilon is the permittivity, A is the area of the contact, V is the voltage applied and D is the distance between the surface. So, this is how in most of the cases these adhesions are taken care by the electrostatic adhesion forces. Now, when we try to consider the torque is a kind of a for legged motion, which is represented as tau. So, the torque is useful when the leg of the micro robots rotates around a hinge to generate a motion. So, for a leg with length L and leg force Fl, the torque generated is considered as T equals Fl into L, which is a kind of a representation over here. Now, one of the important aspect which comes into such kind of walker robot is called as a stability control. So, in most of the cases, if you see, the surface walker always moves. So, let us consider this as a kind of a surface walker. So, this is a kind of a load which is available, and here it's a kind of a two-leg system. So, initially the surface walker is at this particular position, and it is pushing. The surface walker moves due to pushing locomotion, where the force is generated by the micro robot pushes against the resistance and the surface to achieve walking. So, the surface walkers are usually a slow movers, thus a static stability is required. So, the static stability is derived by using a support polygons, a leg position, and the stability of the micro robot is controlled by adjusting the forces and the torques dynamically. So, ideally, when we try to look into the control stability of such kind of simple surface walker when it tries to move in a forward location, it involves two different strategies. One strategy is called as a PID control, and another one is called as the force control. So, let us discuss the which is a kind of a generalized strategies which is being employed for the kind of a control stability. Now, let us talk about this overall control stability for a micro robot. So, one of the key strategy for considering the micro robot stability, which is called as polygon for micro robot stability. So, the support polygon is the area enclosed by the contact point of the micro robot with the surface. So, for continuous walking without tipping of the micro robots, its center mass should lie inside the support of the polygon. Consider a quadruped four-legged micro robot. In this quadruped micro robot, so we have four legs as mentioned, and the center of mass stays over here, and then there is a rectangle, this one. So, all the legs on the surface, so we get a kind of a rectangular, the center of the mass of the micro robot shift towards the most stable position while walking. So, the stability depends upon the position of the center of the mass with reference to the support of the polygon. That is, when all the legs are on the surface, so we get a rectangular profile, and when one more leg is moving, we get a triangle on one when there is one leg in the air. So, that is how these kind of micro stabilities are studied. Now, one of the key parameter which is involved with reference to this stability perspective point of view, which we call it as a stability margin. So, the stability margin is the minimum distance of the projection of center of mass from the support polygon boundary. So, as far as in the center of mass is concerned, the center of mass is available over here, and then M is a kind of a stability margin which is represented in this direction. So, as we had discussed earlier, so we have two different conditions. One is when all the legs are spaced at the point, we get a kind of a rectangle domain, and when one leg is at the free air, we get a triangle or one leg domain. So, in this case, we have a quadruped robot, and then so in these conditions are deployed for a quadruped micro robot. When M is positive, it is inside the support. If M is greater than 0, the micro robot is stable. Whereas, when M is less than or equal to 0, so the micro robot basically tips over. So, higher the positive value of the stability margin provides a better stability to micro robot during a motion. So, this stability margin plays a vital factor in studying the stability of the micro robot towards the motion or towards the requirement. Next, let us consider an hexapod. So, in this particular hexapod, so again we are considering M, and then all the legs are grounded, and then we are trying to trace a hexapod in all that region. Similarly, there is a kind of a 3 leg on the ground. In the case of a 3 leg on the ground, we have 3 positions. These 3 positions are appropriately grounded over here, and then the mass is being placed in this particular position. So, in static position, all 6 legs are on the ground and stability of polygon is hexagon. The center of mass of the micro robot is at the geometric center of the hexagon. While moving, 3 legs are in contact with the ground at a time for a stable gate. Thus, stability polygon reduces to a triangle. Center of mass of the micro robot shift away from the geometric center of the body. That is, if m is greater than 0, the micro robot is stable. If m is less than or equal to 0, the micro robot is tip over. That is, like, this acts as a base condition for micro robot stability towards the surface. Now, when we try to talk about the control strategies of a surface walker, as discussed earlier, when we consider a PID control, that is the proportional integral derivative control, the leg position is controlled based on these generalized equation. That is, u of t, which is nothing but the control signal, is equals kp e of t plus ki integral e of t dt plus kd de of t by dt, where in this e of t is error in position, kp, ki, dt are proportional, integral and derivative gains of the leg position, u of t is the control signal, y of t is the desired position of the leg, and y dash of t is the actual position of the leg. So, the error in the position can be represented as e of t, which is nothing but a difference between the y of t minus y dash of t. Now, when we try to consider a proportional term, it generates the output which is proportional to the error. It is usually a fast response, but high value can lead to a steady state error. So, up of t equals kpe of t, and when we try to consider the integral term which is available, ui of t equals ki e of t dt. It accumulates the past error to eliminate steady state error. It reduces the error over time. As far as the derivative perspective point of view, u d of t equals kd de of t by dt. It reduces the oscillation and it also increases the system stability. So, these are some kind of generalized terminologies. Now, when we try to consider the force control, so the earlier was the PID control. When we try to consider the force control in a micro robot ensures that it moves as a result of pushing against the surface without the slipping. So, in this particular case, so we may need to consider the propulsion force, we may need to consider the normal force, we may need to consider the coefficient of friction. So, in the case of propulsion force, Fp less than or equal to micro Fn. So, micro is the coefficient of friction, Fn is the normal force which is available, Fp is the propulsion force. So, the propulsion force is monitored with force feedback sensor and it is adjusted as per the requirement where we are working upon. So, overall, if I need to summarize, so we had discussed about the control for surface workers. So, we have discussed them the different parameters which are involved, like various force during the motion, which includes the external forces, which includes the gravitational forces, the normal support forces, the frictional forces and the air resistance forces. And when we try to talk about the internal forces, so the propulsion forces, adhesion forces and the torque forces which exhibits over here. So, this is a kind of a generalized formulation how the gravitational force and a normal force will exert the force on the micro robotic system. In addition to this, we also have a frictional force and a drag force which will try to contribute to this particular system. And when we try to talk about an internal forces is concerned, a propulsional force plays a vital role. So, in the case of a propulsional force, so we talk about the legged micro robot and the force generated by all the legs. F1 is the force generated by each leg, and N is the number of leg which is generated. And then we need to consider the adhesion forces. So as far as an adhesion forces perspective point of view, the area of the contact, the voltage applied, and distance plays a vital role. So we need to consider two important parameters. One is the kind of an adhesion force as well as the torque which is being generated over here. And when we try to talk up, so this is a kind of arrangement which we are talking about a surface walker. In the case of a surface walker, it's a kind of a pushing locomotion which exhibits. In order to take care of the control stability, two important strategies are followed. One is a kind of a PID and another one is a kind of a force. And in addition to this, with reference to structural perspective point of view, so there are two types of micro robot stability are exhibited. So one is a kind of a support polygon based system where it's a kind of quadruped four-labbed micro robot, and then like by considering the center of mass, so we are trying to look into the stability of it, and when there is a moving leg which is available, so appropriately these quadruped micro robots will try to deflect and finally it form a triangular base. Similarly, one of the key parameter to understand this process is the kind of a stability margin. So as far as in the stability margin is concerned, all the legs on the surface are there, and appropriately we try to see the kind of a micro robot stability. So a boundary condition is set with reference to the micro robot stability, and we can also consider an hexapod. So with hexapod with all leg ground and the three leg system. As far as control strategies are concerned, so we have discussed about the PID, about the proportional term, the integral term and the derivative term, the generalized equations which are being deployed, the force control and the overall propulsion forces which are being exerted in the system. Okay. So these are some of the references which we have used for preparing these slides, and I acknowledge the authors for the support. Thank you.
thin film by MOF that we have fabricated using different physical vapor deposition techniques such as thermal evaporation or electron beam evaporation that we can use in various applications such as Stewart platform assembly that we are going to show here. So firstly, what we do is we cut different structures such as circle or triangular structure with the help of laser energy with laser micro machining, as we have also discussed previously. So the same structures we use for fabrication of Stewart platform assembly. So this Stewart platform assembly is basically what we have learned in different studies also. Like the base is a fixed base on which we have a moving platform, which in our case is a mirror, which is a lightweight mirror, which is in the central part. As you can see here, this is our central part, which is the movable platform or the mirror. And that mirror, it is supported using four different actuators. So all the parts are NITI SMA based, and they have been micro machined using laser energy of the fiber method. And then this structure, in this structure, the mirror, it is being moved with the help of the motion of these four actuators individually or in combination. So when we supply energy, electrical energy to any one of the actuator, it will actuate in forward direction, as we have seen in electrical actuation video also, that when we apply the energy, the actuator will move in the forward direction, and because of that forward motion, our mirror will tilt in upward direction or downward direction according to the motion of the actuator beneath it. And because of that motion, our mirror tilting will be there, and that mirror tilting we will be using for further application of laser beam steering for, let's say, optical scanning or optical communication applications. So the first thing here is you can see there are argo markers. So these argo markers are basically used for position detection of the mirror, so that we can accurately determine at what position or what angle our mirror is currently at. So we have put, for simplification, we have put three different argo markers at different positions of the mirror. And initially at horizontal position, what happens? There is a camera on the top. As you can see here, there is a camera on the top. So that camera continuously monitors the position of the argo markers. So initially our mirror is at horizontal position, and in that position, the camera, it takes the position of these three argo markers, generate the equation of a plane which corresponds to the horizontal position of the mirror. And as we supply power to any one of the actuators, this mirror will actuate, this mirror will tilt, and because of that tilting, the position of the argo markers with respect to our camera, it will change. And as it changes, the new position will be detected by the camera, and it will again generate an equation of new plane, and will give the final angles of the plane or the mirror with respect to the initial position. So, like here you can see in this part. So, when our mirror is moving, the x and y positions are changing. So, these red, blue, and green lines, they are the x, y, and z axis of the argo markers. And as our mirror is moving, these positions are also changing and our angles are changing. Here. So we can get a live feed of what our angles are and what is the position of mirror is. And the same we can use as a feedback to control the input power of, to the actuator, so that we can control the final position of the mirror